This video is a continuation of the variables notebook and will discuss statements in R. Statements in R are syntactically correct expressions, where an expression can consist of only a single constant, or perhaps a variable, or it can be a compound expression built from other expressions or parts, like functions and operators and so forth. Statements can be separated by new lines or by semicolons. Now, in all the examples we've seen so far, we've used new lines to separate our statements. In the interpreter, we have written complete statements and then hit enter to execute them. In Jupyter Notebook, we've entered statements one per line and then executed the code block containing those statements. However, in all cases, when the interpreter determines that a statement is complete, it will then evaluate that statement and return its value. The value of the statement can be assigned to a variable, as in the above examples, or if the resulting value of the statement is not assigned to a variable, then it is printed to the console and the value is lost, meaning that we cannot recall that value for reuse without reevaluating the original statement. So in this example, I'm simply going to multiply 5 and 4, and I'm not going to assign the result to any variable. This means that the interpreter will simply print out the result, and we can't retrieve it without actually reevaluating the multiplication. In this code block, we only had a single statement, but let's say we had two statements, each on its own line. So maybe we assign the value of 5 to x, and then assign y the result of x times 3. Now this is no different than the examples we've seen so far. The interpreter executes each line separately since it recognizes that each is a complete statement. Now, if we wrote this using only a single line, we would need to separate each of these statements with a semicolon, like so. The semicolon tells the interpreter that we're ending the current statement, and assuming that it's syntactically correct, the interpreter will evaluate it before reading the next statement. Both these code blocks perform the exact same computation, and they really only differ on the use of the semicolon or new line. The interpreter basically treats them the exact same way. So to show you this is true, I'm going to write statements that have some output. So let's instead write x semicolon y. Now when the interpreter reads the first complete statement, x, it sees there's no assignment, and so it outputs the value of x. The same thing occurs when it reads the complete statement y. And when we execute this code block, we see that both values are in fact output just as we expected, one per line. And so the interpreter is treating this single line of code with two complete statements the same as it had our previous examples where we had one statement per line. So far, all the examples have been simple statements. A compound statement, which is sometimes referred to as a block, is a group of statements that are enclosed in curly braces. With a set of simple statements, the interpreter evaluates each statement one after another as they're read, treating each independently. This is not the case for compound statements, as the interpreter is going to wait until the compound statement is completely read before evaluating it. And as a consequence of that, only the value of the last statement within the compound statement is used as the value of the compound statement. To see this, let's create a compound statement using the last example where we output both x and y. So to do this, I'm going to type inside curly braces x semicolon y, and then I'm going to run this code block. We see here that the output is the value 15, which was the value of y, which is the last statement in this compound statement. If we go back to look at the previous example, we'll see that the value 5 was output from the first simple statement x, and that the next statement y output 15. In our compound statement example, we see that x was not output even though there was no assignment, but the value for y was output. And this occurred because the value of the compound statement, as I said, is the value of the last statement within the block, which was y in this case. So far, we've been using complete statements. That is, we are providing lines of code that are syntactically correct and complete within each of the code blocks before executing the block. In Jupyter Notebook, if we were to give an incomplete statement, perhaps we omit the right side of an assignment as in the example text below, then the interpreter would actually give us back an error. However, if we were to do the exact same thing in, say, the R console or the interpreter running in the terminal, then the interpreter would actually present us with a secondary prompt indicating that it has detected that the current statement is incomplete. The secondary prompt is represented by the plus character you see in this example. So we're actually going to switch over to a terminal and try this out. So if I type X and then the left arrow and hit enter, we see that the secondary prompt comes up, letting us know that the interpreter is waiting for us to finish the current statement. So I'm going to type 4 and hit enter. And now the interpreter recognizes that the statement is complete and evaluates it. Since this was an assignment, no output was generated, and the primary prompt was displayed for us again. If I now type X and hit enter, we get the output 4, showing us that indeed our previous statement was evaluated as we expected. The interpreter will actually continue to give us the secondary prompt as long as it doesn't find the end of a complete statement. So if we do this again, and I hit enter, say a few times, the secondary prompt will be presented until I finally complete the assignment here,